The overall goal of this method is to fabricate concave spherical microwells by utilizing magnetic force-assisted self-locking metallic beads.
Hi, my name is Gi-Hun and I'm a PhD student at Chung-Ang University. What we are interested in our lab is fabricating various microscale devices and platforms to enhance studies regarding the development of bioinstruments, cell culture, and novel microstructures. One of our research interests is developing novel microdevices and methodologies to culture cells in a three-dimensional environment. We call this 3D space culture. 3D space culture is very useful for understanding 3D cellular response because it is more similar to the actual tissue than the conventional two-dimensional planar culture. Several methods for spread production have been attempted, such as spinner flask, roller tubes, hanging drumlet, and microwell. Among these methods, the concave microwell method is a very powerful tool to produce such 3D spheroids. Benefits of the microwell are easier monitoring and the ability to control spheroid sizes and distribution. Here, we propose a robust method for fabricating concave microwells utilizing steel beads, a throw array, and an array of small magnets. Using this technique, hundreds of concave microwells can be fabricated by mechanism of magnetic force assisted self-locking steel beads. The advantages in this fabrication process is its cost efficiency and no requirement of professional skills.
To start off, 230 by 30 through